A cylindrical vessel whose diameter and height both are equal to 30 cm is placed on an horizontal table as shown, and a small particle P is placed in it at a distance 5 from the center. An eye is located at a position such that the edge of the bottom is just visible. The particle P is in the plane of drawing. Up to what maximum height should the water be poured in the vessel to make the particle P visible? Alright, now this question requires a bit of construction. Fine. Now let's say I poured the water to a height D. Alright, and I just want that this particle P is visible. So the ray should trace the path like this. That is, the rays emerging from point P should reach the eye. Alright, now do one thing, that draw the normal at this very point, stretch it to the bottom, and this is my center, let's say. So the center is, this distance will be 15 because the diameter is 30 cm that is given to me. So let's say this distance from the center, this is the center, this distance is 5 that is given to me, and the total distance is 15, so this distance will be 10. Alright, now what I have to do is, now simply applying the Snell's law. Fine, let's say this is my angle of incidence with the normal, this is my angle of refraction, so I can write mu of water into sine of I is equals to mu of air into sine of R. Fine. Now by geometry, this is angle R, so this angle will also be R. Alright, and if this angle is R, then tan of R will be equal to this distance, that is the height of cylinder, and to the ratio of the base of the cylinder, and both are equal, that is 30 and 30, so it comes out to be 1. So the value of R comes out to be 45 degree. So I do have mu of water into sine of I is equal to mu air, that is 1, and sine R will be sine 45, that is 1 by root 2. Now sine of water is 4 by 3 into sine I is equal to 1 by root 2. So sine I comes out to be 3 into 4 root 2. Alright, now let us assume that this distance is x. So what I can write is tan of I is equal to x plus d, x by d. Alright, and also that I know that tan of R can be written as perpendicular, that is, by geometry I can say that if this angle is R, then this angle will also be R. So tan of R will be equal to tan plus x by d. So tan R is equal to obviously 1, so d is equal to tan plus x. Now I do have a relation between x and d now. Now sine I value is known to me, so I need a little bit Pythagoras theorem, that if this is 3, this is 4 root 2, I can get the value of this side, that comes out to be, I think, 29. Alright, now tan I can be written as 3 by root of 29, that is equals to x by d, where x is what I have to find, or sorry, d is the value that I have to find. So x can be replaced by d minus 10 by d. So simply solve this equation for the value of d. The value of d comes out to be 26.7 centimeter.